Okay, 1.7, basic matrix operations. I'm hoping Wednesday to get graphing calculators and do some stuff with the graphing calculators with our systems of equations and our matrices. So, let's talk about basic matrix operations for today. So, sorry if this is tiny. I'm sorry. This is in your book. I'm just going to kind of talk about it a little bit. Okay? And I'll read it out loud for us. A matrix is a rectangular arrangement of numbers. The dimension of a matrix with m rows, m as in McAllister, and n columns, n as in Nutella, are m by n, and it's read m by n. M times n, m by n. So the dimensions of this matrix A is 2 by 3, because it's got 2 rows and 3 columns. Pretty straightforward, right? It's got 2 rows, 3 columns, so it's 2 by 3. It's 2 by 3 matrix. Okay? The numbers in the matrix are called its elements. So each number in this matrix is an element of that matrix. Okay? So the element in the first row and third column is 5. First row, third column, 5. A matrix derived from a system of linear equations. We've been talking about systems of linear equations, right? So a system derived from a system of linear equations, each written in standard form with the constant term on the right. Standard form would be ax plus by, plus cz equals k. That would be standard form. All my variables are on the left, my constants on the right. So, a matrix derived from a system of linear equations, each written in standard form with the constant term on the right, is what we call an augmented matrix of that system. For example, this system down here, below, can be represented by the given augmented matrix. We just use the coefficients of each equation. So 5, 3, negative 2, and then 1's my constant. 5, 3, negative 2, 1. 1, 2, 3, negative 1. 1, 2, 3, negative 1. Does everyone see that? You just take the coefficient from in front of each variable, and it goes in our matrix. 3, negative 4, 1, 10. 3, negative 4, 1, 10. That's what we call our augmented matrix, is if we're getting a matrix from our system of equations. Before you write an augmented matrix, you have to make sure each equation in the system is written in standard form like we already talked about. Include zeros for the coefficients of any missing variables. So if there's not a y variable there, so say this y was not here. Golly. Say that y was not there. It was just x plus 3z equals negative 1. I would include a 0 right here. Right here. It's going to pop up here in a second. There we go. I'd include a 0 right there to take the place of that y value. Does that make sense? If that y is not there, I'd write a 0. Okay? That's what it means when it says include zeros for the coefficients of any missing variables. This determines the order of the constants and coefficients in the augmented matrix. So that may be kind of confusing to you for right now. But let's talk about some operations with our matrices. Okay? Adding and subtracting matrices. The plural form of matrix is matrices. Don't call them matrices. Okay? And don't call a single matrix a matrice. Say matrix, and the plural form is matrices. So adding and subtracting matrices. To add or subtract two matrices with the same dimensions, that is important. The dimensions must be the same for you to add or subtract them. You add or subtract their corresponding elements. So, here, we're adding two matrices. I've got the matrix A, B, C, D. The matrix E, F, G, H, I'm adding them. First off, what are the dimensions of this matrix? How many rows are in this?
2 by 2.
2, so 2 by 2. What are the dimensions of this matrix?
2 by 2.
2 by 2. They are the same dimensions, so I am able to add them. So what I do? A and E are corresponding elements, correct? They're in the same position in each of their matrices. Right? Does that make sense? Corresponding positions. So I just add A plus E. I add B plus F. C plus G. D plus H. And that gives me my new matrix. Pretty easy. Same thing with subtraction. What are the dimensions of this matrix?
2 by 2.
2 by 2. What are the dimensions of this one? 2 by 2. So I can subtract them. So I just subtract the corresponding elements. So A minus E, B minus F, C minus G. And they go in the same corresponding spot that they both are. D minus H. Okay? So, let's say you have two matrices that do not have the same dimensions. The sum or difference of two matrices with different dimensions is undefined. So if I get a 2 by 3 matrix plus a 3 by 2 matrix, I would just write undefined because I cannot add or subtract them. Okay? So that's pretty easy. Are there any questions about adding or subtracting matrices before we look at some examples, and hopefully it makes a little more sense? Hopefully you can see it better. Can I get to my examples? Okay. Can you all see that a little better? Okay. So my first matrix is 2, -1, 3, and 0. Plus my second matrix, which is 1, 2, 4, -2. So, for my top left corner of my new matrix, which two numbers am I adding?
2 and 1.
2 and 1, because they're in corresponding positions, correct?
Yeah.
So I'm doing 2 plus 1.
Can we write it down first?
Does everyone see it? Yes, sorry. I didn't even think about that. I'll let you get it written down first. What are the dimensions of both of these matrices?
2 by 2.
They're both 2 by 2, so I can add them, correct?
Yep.
Everyone got it written down? Okay. So for my bottom left corner, which two numbers am I adding? 3 and 4, because they're in corresponding positions. So 3 plus 4. For my top right, which two numbers am I adding? -1 plus 2. And my bottom right, which two numbers am I adding? 0 and -2. Does everyone see that? So now let's go ahead and add. 2 plus 1?
3,
3 plus 4,
7,
7, -1 plus 2,
H 1.
1, 0 plus -2, -2. There's my answer.
That's that whole answer.
That's my answer.
Wow.
Easy. Like I said. Okay, if you want to skip this middle step, I'm okay with it. I just wanted to show you what we were doing. Okay? So if you just jump from here to my answer, that's okay. Because you're just adding. 2 plus 1, 3. 3 plus 4, 7. -1 plus 2, 1. 0 plus -2, 2. -2. And we're good with that. Adding matrices. Okay, letter B. What are the dimensions of my first matrix?
3 by 2.
3 by 2. What are the dimensions of my second matrix?
3 by
3 by 2. So can I subtract them?
No. Wait, what?
Can I subtract them?
Yeah.
Yep, they've got the same dimensions, right?
Yeah.
So I can subtract. Okay, for my top left, which two numbers am I subtracting?
2, -1.
So 2 minus negative 1. Be careful with your signs on subtraction. I've got to do 2 minus negative 1. For my middle left, which two numbers am I subtracting?
5 and 7.
5 and 7, because they're in the same position. So 5 minus 7. Everyone with me? Bottom left,
Negative 2, negative 5.
negative 2 minus negative 5. Everyone good with that whole left side? Okay, my top right. What am I subtracting? Negative 3
2.
minus 2. Middle right.
4 minus 8.
4 minus 8. And bottom right.
8 minus 6.
8 minus 6. Everyone okay with what I'm subtracting here? Okay, 2 minus negative 1. What does this turn into?
2 plus 1.
2 plus 1. Stay, change, change. What's 2 plus 1?
3.
3. Am I moving too fast for anyone? 5 minus 7?
Negative 2.
Negative 2. Negative 2 minus negative 5?
3.
3, because that turns into negative 2 plus 5. Negative 3 minus 2?
Negative 5.
Negative 5. 4 minus 8?
Negative 4.
Negative 4. 8 minus 6?
2.
2. There's my answer. Questions on B? Not too bad? Okay, letter C. What are the dimensions of my first matrix?
You can't do that.
What are the dimensions of my first matrix? 2 by 3. Make sure you do rows first and then columns. 2 by 3. What are the dimensions of my second matrix?
2 by 2.
2 by 2. Can I add these?
No.
No, so what's my answer?
Undefined.
Undefined.
Hold up, I'm lost. Can you explain that again?
Explain what?
Just like the bottom one.
Yes. So my first matrix is a 2 by 3 matrix. It's got 2 rows and 3 columns. Right? My second matrix is 2 by 2. It's got 2 rows, 2 columns. In order to add or subtract matrices, they have to have the same dimensions. Since they don't have the same dimensions, it's undefined.
Okay.
That happens all the time?
Nope. Do what?
That happens all the time, like when it's like that, it's just undefined.
Yeah, just undefined. Same thing if I was subtracting here. If I tried to subtract these 2 matrices, I'd write undefined. Question?
So are we going to do multiplication and division?
We're about to talk about a little bit about multiplication. Can I move on from adding and subtracting?
Mm-hmm.
Okay. Okay, scalar multiplication. This is still easy, don't worry. When working with matrices, a real number is often called a scalar. S-C-A-L-A-R. Scalar. To multiply a matrix by a scalar, multiply each element. Remember, the numbers in the matrix are called an element. So multiply each number in the matrix by that scalar. This process is called scalar multiplication. So here's a little example with just variables. If I have k times the matrix A, B, C, D, I just multiply k by each number in there. So k times A, k times B, k times C, k times D. Everyone good with that? Not too bad? Is anyone writing this, or can I move on? Move on. Okay, letter A. We've got 2 times the matrix 3, negative 2, 1, 5, 2, 0. I'll let you write it down before I move on. Can I go ahead and begin? For the top left What two numbers am I multiplying?
2 and 3.
2 and 3. I'm just multiplying this 2 on the outside, my scalar, by each number in here, in my matrix. So for the middle left, which two numbers am I multiplying? 2 and 1. The bottom left,
2 and 2.
2 times 2. Top right,
2 and negative
2 and negative 2. Middle right,
2. 2 and 5.
2 and 5. And bottom right,
2 and 0.
2 and 0. Everyone with me? Pretty straightforward. So let's get my answer. 2 times 3,
6.
2 times 1, 2, 2 times 2, 4, 2 times negative 2, negative 4, 2 times 5, 10, 2 times 0, 0. There's my answer. Pretty easy? Not too bad? Can I erase letter A and move to letter B? Letter B. I've got negative 3 times my matrix 5, 0, negative 2, 4. Plus my other matrix, negative 1, 7, 3, 2. Do you guys think I need to multiply first or add first?
Multiply.
Multiply. Order of operations, right? Multiplication comes before addition. So I'm going to multiply my negative 3 times that first matrix first. Is everyone okay if I skip the step of writing what we're multiplying? Okay, negative 3 times 5. Negative 15. Negative 3 times negative 2. 6. Negative 3 times 0. 0. Negative 3 times 4. Negative 12. There's my new matrix after multiplying that negative 3 through. Plus, I still have this other matrix. Everyone got that? Now, I can just add these two matrices. Well, maybe. My first matrix, what are the dimensions of it? What are the dimensions of my first matrix now?
Oh, 2.
2 by
2.
2. There's 2 rows, 2 columns. 2 by 2. What are the dimensions of my second matrix now?
2 by 2.
2 by 2. So can I add them?
Yeah.
Yep, they've got the same dimensions. Okay, negative 15 plus negative 1. Negative 16. 6 plus 3. 9. 0 plus 7. 7. Negative 12 plus 2. Negative 10. Have I done all the operations it's asked me to do? Yeah, there's my answer. Y'all agree with me? It's easy? Not too bad? Okay. Can I move on?
There's more.
All right.
Oh.
Okay.
Nice little word problem here.
I'm so sick of you.
A high school district track and field organization used the same standard qualifying times for its 100-meter run district championships in 2 consecutive years. The table below shows the numbers of boys and girls in the 3 class levels who qualified for the district championships in the 2 years. Organize the data using 2 matrices, one for 2015 and one for 2016. Then find and interpret a matrix giving the average number of qualifiers in each class and gender. All right, here we go. What do you think my first matrix is going to look like?
The first boys.
Well, it says a matrix, one for 2015, and 1 for 2016. So I'm going to have a boys and a girls in the 2015
Oh.
and a boys and girls in 2016, correct?
Yes.
So what are they going to look like? What's my first matrix going to look like for 2015?
Is that an 18?
That's an 18.
18, 20. What? I'm so confused.
Hold on, is it
18 and 21.
What's going to be my first column in my first matrix?
18?
18?
23?
16.
18, 23, 20, or 16, correct? That's 2015. What's going to be my second column in that matrix?
16,
21.
25, 12.
21, 22, 24.
21, 22, and 24. Because remember, it wants a matrix for 2015 and a matrix for 2016. So my first matrix, this is going to be my first column, 18, 23, 16. My second column is going to be 21, 22, 24.
Okay.
Because that's for 2015, right?
Yeah.
So what's my second matrix going to look like? What's the first column?
16, 25, 12.
2016 for the boys. And then what's the second column going to look like in my second matrix?
15, 18, 18.
15, 18, 18. 2016 for the girls. Right? Does everyone understand that? Yes.
What's the last number for the second column?
That one?
Yeah.
12. So, here are my two matrices. Like we said, 18, 23, 16. 21, 22, 24. That's for 2015 for boys and girls. 16, 25, 12. 15, 18, 18 for my second matrix. That's 2016 for boys and girls. So that's step one. Wanted me to put my data into two matrices, correct? So I've done that. What else is it asking? After it tells me to organize the data into two matrices.
Then find and interpret a matrix giving the average number of qualifiers in each class and gender.
Then find and interpret a matrix giving the average number of qualifiers in each class and gender. How do I find the average of something?
Add them up and then divide
Oh
by
my
the
god,
number.
I
Add them up and then divide by
How many there are?
how many there are. We're going to kind of do that here, except with our matrices. Okay? So what do you think I'm going to do with the two matrices first? Add them, and then divide by what?
12.
Well, yeah.
Well, how many matrices are there?
2.
Two. So I'm going to divide by
2.
2. Okay? So a little formula for that. We didn't talk about division, did we? Would be the same thing as dividing by 2, though. Multiplying by what fraction? What? Times 0.5 or 1/2, right? So, my first matrix is matrix A. That's what this A stands for. The second matrix is matrix B. So we said to add the two matrices up and then divide by 2, correct? So here's my little formula. 1/2 times A plus B. So now I'm just going to fill in the two matrices. Nope. Everyone with me? I just plugged in my two matrices for A and B. Because my first matrix is matrix A, second matrix is matrix B. Everyone caught up to where I'm at? So now my 1/2 is outside the parentheses. So I'm going to add the two matrices first and then multiply, right? Okay. So 18 plus 16.
34.
What?
34.
34. that a little smaller. $23 plus 25.
48.
48.
Sorry.
16 plus 12. 28. 21 plus 15. 36. 22 plus 18. 40. And then 24 plus 18. 42.
Wait a minute.
Questions how I added those two matrices. Remember, to add them, you just add the corresponding elements. Questions on that? Now, I've done everything in the parentheses, correct? Now what can I do? My scalar multiplication, right? So I'm multiplying every element in my matrix by 1/2. So what's 1/2 times 34? Or half of 34? 17. 1/2 times 48 or half of 48? 24. 1/2 times 28? 14. Am I moving too fast? 1/2 times 36? 18. 1/2 times 40? 20. 1/2 times 42? 21. So there's my average in matrix form. Correct? So, I've got to answer the question. Find and interpret a matrix giving the average number of qualifiers in each class and gender.
I think something is the same.
So, my first row is class 1, correct?
Put the damn.
My first row is class 1, correct? Correct? My first row is class 1. So this is the average for boys in class 1 and girls in class 1. My second row is class 2. So, this is my average for boys in class 2 and girls in class 2. My third row is class 3. So this is the average for boys in class 3 and girls in class 3. Everyone see that? So, to write that out, the average number of runners for the 2 years was 17 for boys and 18 for girls. In class 1. 24 for boys and 20 for girls in class 2. And 14 for boys and 21. Erase, give me a little more room.
That's the whole paragraph. Whole essay.
We understand.
And 21 for girls in class 3. That'd be my answer. Does everyone see how we got that? We just found the average of the two matrices.
Yes.
Okay? there any questions about any of our notes for today?
No.
We okay?
Yes.
Pretty easy overall?
No, just not that.
Here's our assignment. Pages 51 through 52, 2 through 24 evens. You only have one word problem.
Oh,
Are you serious?
Just one. The rest should be addition, subtraction, scalar multiplication. And some of the addition and subtraction you won't be able to do if they're not the same dimensions, correct?
Yeah.
So get this assignment written down. This is in your textbook. We have an assignment due today, tomorrow, and Wednesday, correct?
I think
What's it gonna?
So this will be due Thursday,
I'm not in the paper, so
I love the
it's a big deal.
We have
10:07 on Canvas. Okay? Everyone got it? Like I said, we'll review for the test on Thursday. We'll test Friday. As of right now. Those plans could change a little bit, but that's what I'm planning for right now. Okay? Any questions before I end the recording about the notes?